Welcome to this explainer. Look, if you're a business or tech professional right now, you know exactly what's happening. We are all acutely aware of the massive, almost unbelievable investments being poured into AI compute. The standard narrative, it's always just feed the models more data, build bigger data centers, and eventually magic happens. But today, we're going to fundamentally shift your mental model of AI emergence. We're moving away from that brute force, black box mystery, and we're going to see how emergence can actually become a predictable, engineered reality.
Here is the roadmap for today. We'll start with waiting for AI emergence, then dive into a really fascinating puzzle called Pluto, Cat, and Suitcase. After that, we'll unpack the structural compression reveal, witness a microphase transition, and finally wrap up with engineering the AI future.
All right, part 1, waiting for AI emergence. So right now, enterprise leaders are practically drowning in this idea that bigger is always better for AI. The playbook is basically pouring eye-watering amounts of money and compute into systems, and then, well, just waiting for magical new capabilities to emerge. But the energetic paradigm, or EP, totally challenges this status quo with one absolutely crucial anchor point. Bigger models wait for emergence. EP already engineers it. Instead of just crossing our fingers and passively waiting, we are actively designing the structural conditions for it.
Which brings us to part 2, Pluto, Cat, and Suitcase.
To really grasp why EMP matters to your enterprise architecture, without just throwing more servers at the problem, I want you to think about a puzzle. Take 3 completely unrelated objects. We've got Pluto, a cat, and a suitcase. You've got astronomy, biology, and, well, mundane everyday luggage. So what could they possibly share?
Well, at the surface level, there is a vast semantic distance between them. I mean, they share absolutely nothing, right? Different materials, vastly different scales, totally different vocabularies. But if we kind of just suspend that surface-level meaning for a second and look strictly at their structural roles, we find something amazing: geometric equivalence. They actually share the exact same underlying pattern based on boundaries and stability.
Let's break that structural pattern down a bit. Think about it. Pluto is a body stabilized within a gravitational boundary. A cat? That's a self-regulating biological system maintaining internal equilibrium against its environment. And the suitcase is simply a movable, bounded domain preserving internal order against external disturbances. Structurally speaking, they are all doing the exact same job.
Moving right along to part 3, the structural compression reveal.
This brings us to the core mechanism that EP leverages to basically bypass the need for massive brute force compute. It's called structural compression. This is the process where scattered information and semantically distant concepts collapse into a higher-order geometrically equivalent structure. It reveals the hidden invariants across different domains, compressing them into the exact same structural pattern. And the best part? It does this without needing a single extra terabyte of training data.
Here's the exact step-by-step path of how this actually happens. Step 1, we start at that semantic distance, acknowledging those massive surface-level differences we talked about. Step 2, we move into functional abstraction, where we identify their shared roles like boundaries and stability. And finally, step 3, topological compression. This is where all 3 of those seemingly completely unrelated objects are mathematically and structurally compressed into what we call bounded attractor systems.
Picture this process. Those 3 distinct objects, Pluto, the cat, the suitcase, they dissolve into one shared topology map. They aren't separate entities anymore. They become a single map featuring a bounded domain, a stable state, and external perturbation. All those surface differences just melt away, and what you're left with is pure structural architecture.
Part 4, a microphase transition.
Now, what we just walked through isn't just some clever teaching analogy. It represents a literal microemergence event happening right in front of you. You see, EP doesn't just promise this as some distant future feature. It already achieves microemergence in demonstration form. Those 3 distant objects collapsing into one bounded attractor class through structural compression, that is emergence happening structurally. It entirely bypasses the need to add more information or more compute.
Let's put this in stark strategic contrast for your business. The old paradigm basically dictates that to get new capabilities, you have to add more data and drastically crank up your compute costs. It's exhausting. But the energetic paradigm? It achieves a microphase transition simply by changing the representational structure itself. Semantic distance collapses into geometric equivalence. No extra servers required. It's a total game changer.
And finally, Part 5, Engineering the AI Future.
For those of you guiding technology strategy, this completely reframes emergence from a magical black box into a solvable engineering problem. Now, to be completely clear here, we aren't claiming that EP has magically solved every single frontier-scale AI problem today. That's not the point. The vital takeaway is that EP already achieves this structural mechanism conceptually and experimentally right now. It proves the plumbing actually works.
I love this thought. Emergence can be the moment when hidden invariance becomes visible. This proves that a brand new capability in an AI system can appear, not because you shoveled a mountain of data into it, but simply by making hidden structural invariance visible across systems that previously looked totally unrelated. It's really about working smarter at the foundational level of architecture.
So, the big strategic takeaway for your enterprise architecture is crystallized right here. Bigger models wait for emergence. EP already engineers the structural conditions that make emergence achievable, stable, and testable. It gives you actual control over the process, allowing you to build AI systems that are structurally intelligent by design.
As we wrap up this explainer, I want to leave you with a really provocative question for your own technology roadmaps. When you look at your massive investments in AI, you have to ask yourself, are you going to keep paying a premium to build systems that just sit around and wait for emergence? Or are you ready to fundamentally change the structure and actually start engineering it?